Hello and welcome back to Ganesh Institute. So in today's video, we are going to discuss about irreducibility. So what is irreducibility? To understand that, let's first talk about reducibility. So when we say reducible, that means we are able to factorize a particular expression, okay? For example, if I'm talking about x square plus 2x plus 1 equals 0, I can write it as x plus 1 whole square, right? So that means x can be, because this is a quadratic equation, quadratic means degree 2, and degree 2, that is highest power of variable is 2, that's why it is quadratic. So it will be having two roots. Roots are equivalent to number of roots are equivalent to degree. Okay, so because this equation has been transformed or reduced into these two factors, so we will say that this equation is reducible. Okay, now let's talk about this x square plus 1 equals 0. If I talk about that, this is the equation where x belongs to complex field. So you can see x will be minus 1 and that too the square root of minus 1. And we know that minus 1 is iota when we talk about complex numbers. So this equation is also reducible. Okay. But for which field? For the field of complex numbers. But if it would have been, the condition would have been x belongs to rational numbers, then we would have said that no, because x is plus minus root minus 1, so there is no existing root for which belong to this rational number field. So then that would become irreducible. That means cannot be reduced. Getting it? Now, in order to find out whether a particular equation or polynomial can be, we can find out whether it is reducible or irreducible using Eisenstein's criteria. Okay, so we know what is polynomial. Any expression of the form a0, a1x, a2x square, a3x cube up to so on, an xn, right? So let's say it belongs to zx. Okay, now a0, a1, a2, what are these? These are the coefficients, and x raised to power 0, x raised to power 1, except these, all these are variables. So Eisenstein's criteria state that if you have an expression and there exists, this is the sign of there exists, a prime number, and that prime, let's say it is p for general solution. If there exists a prime number for that particular expression, which one? a0, a1x, a2x square, a3x cube up to so on, plus an xn. If there exists a prime number p, so Eisenstein's criteria states that this p should satisfy this, that it should divide all the coefficients except with the highest degree. Okay, so except an, this p should divide all of these coefficients, so that's why I marked n minus 1, but p should not divide an, that is the last coefficient. Also p squared should not divide a0, that is the constant term. Then we will say the Eisenstein criteria states that if there is a p prime number for this particular expression for which p divides a naught, a1, a2, a3 and up to so on, the second last coefficient. And p does not divide the coefficient with the highest power, and p square does not divide the constant term, then this fx, this polynomial is irreducible over q. Q means rational number. Okay, now you might be wondering what is that. So let's talk about one example. Let's say we have a function, a polynomial. This is 2 plus 6x plus 4x cube plus 6x4 plus x5 belongs to q. Okay, and you have to check the irreducibility using Eisenstein's criteria, okay, in q. So let's see how does it work. Now tell me, what is a naught here, the constant term? What is a1? 6. What is a2? It is the coefficient with x square, but x square is not there. So a3, coefficient with x cube, coefficient with x4, coefficient with x5. That is 1, because this is having only 1 as numerical coefficient. Okay, now I have marked everything. Now what I'm supposed to write? I need to choose one prime number, right? That should satisfy that p divides every single coefficient except the highest power one. So that means up to x raised to power 4, that is up to a4. And p should not divide what? P should not divide, what's the condition? The highest power coefficient, that is a5. And p square should not divide the constant term. Can you suggest me one prime number? Can I take p as 2? So if I write 2, can you see or can you say that 2 divides a naught, that is 2, 4, a1 is what? Hold on. So a naught, which is 2, a1 which is 6, a2 which is 0, a3 which is 4, a4 which is 6, and that's it. So can we see that 2 is dividing every single number here? Correct. So this condition is satisfied. What is next? So for next, see here, the second condition, p should not divide the coefficient with the highest degree. So 2 does not divide the coefficient with the highest degree, that is 1. Yes, that's true. And 2 square, that is 4, should not divide the constant term. What is constant term here? 2. So yes, 4 does not divide 2. So because we can find out one prime number which is following the Eisenstein's criteria, that means this function is irreducible in Q. I'm hoping that it is clear. Alright then, I'm hoping that you've got it, and if so, then don't forget to like, share and subscribe my channel. Till my next video, take care of yourself. Bye bye.